nanohub.org.
Online simulation and more for nanotechnology.
So we're going to play quantum tic-tac-toe, which is literally an entanglement analog of the classic game. And it's the game of champions, by the way. So you all have the game board in front of you. And right now, the game board looks very different than a classical game board, in as much as that it is highly divided. So each square is going to be referred to as a principal square. So the 9 principal squares will be exactly like your classical tic-tac-toe squares. Okay? So a tic-tac-toe will be achieved in the same way. 3 large X's on the 3 principal squares will give you a tic-tac-toe, or O's if you prefer. I'm an X-man. The only difference is gameplay is going to be taking place on the small squares. We okay? So the game deals with superpositions, which is, again, one object in 2 different states. So if we let X go first, he makes 2 simultaneous moves. X1, the first play for X, can be in 2 different principal squares, which is saying X1 is in a superposition of principal 1 and principal 6. Now, each person will continue playing like this until we get a closed cycle. So we have X1's first move. O1 will make another entangled move. Here and here, 4 and 6. X will make his second move in 1 and 4. Now, X2 here will refer to, well, let's go in cycle. X2 here refers to X2 here, right? Well, that refers to O1, which refers to O1, referring to X1, which refers to X1, back to X2 exactly where we started. So we've in effect made a circle in the system. And anytime a player makes this circle, and we'll try and make this a little clearer here in a minute because we have examples. Anytime a player makes the closed loop, the system has to be observed. So like the Schrodinger cat in Jonathan's talk, our system exists in 2 different states right now. And when we observe the system, only one of those 2 states will take place. So our game board here just cleaned off. So just prior to the observation, 2 unique paths exist in the system. Here, where this guy collapses to X, O, and then X, and then in contra, X, X, O. Wait for it, we'll go through. So player X, since he closed the loop, gets to observe the system, and he'll find that this path is maybe better for his ability to win because he just needs to put an X right here. So player 1, therefore, will choose to observe X2 in square 4. What that means is that when he observes X2 here, that square holds an X. That means, by definition, since X2 is here, this has to be X1. If X1 is here, this has to be O1. So we observe X, X, O after he's declared which one takes place. Okay? So, where do we need to go? Okay? So, let's play a game. So, we're going to keep track of the player's moves over here, and we're going to place the markers over here. So, yes, these example games, please jot them down. That's why you have 8 sheets. Sure.
So whoever makes the first move, are they automatically going to be the one who gets to observe?
No.
Okay.
You can, at any player, once the board gets more and more full, either player has opportunities to close loops.
Okay.
But it's always the closer that gets to observe. So the one who made the move that actually closed the loop, they get to make the decision on where the occupies. Okay? So X's first move, he's going to put his first move in both 6 and in 7.
Okay, so I have a question. Right?
Sure.
So you did 6. So if you did 6-1.
Yeah.
Can I do 5-5?
So the second ordinate is just so it's easier to keep track of which one was there first. Yeah, I put those there.
Okay, so if I put one in a 1, I have to put another one in a 1.
Hopefully, yes.
Hopefully? Why?
Well, so when the board gets more occupied, let's say O wants to put his marker in 8-7. He'll put O1 here in 8-1, O2 in 7-2. Because 7-1's already been occupied.
So you have to go to
The next non-occupied box.
the next non-occupied number.
Yeah.
But let's say, going back to your example, so if I put mine in 8-1,
Okay. And where else?
well, but let's say that 2-1 is available.
Mm-hmm.
Do I have to go to 2-1 or can I go to 7-2?
Well, that's your choice, right?
That's what I'm asking.
Exactly.
That is my choice.
Yeah. So you can choose to put your marker in any of the principal boxes.
But it still has to be, it has to coordinate with the number that you're in first if it's available.
Try and reword that.
I
So you have
think
to go in numerical
what
order.
it is
You have to go in numerical order.
I think the boxes up there or in here are literally just to help you keep track of.
Yeah, that's exactly it.
Right, man?
So if you put it in, say in that case, if you put it in 8-1, it doesn't have to go in the first box of any of them. It can go into the second box if that's there, or the third box if you haven't had
It's just to keep track.
It's just to keep track of the moves. Yeah.
Okay.
It's an easier way of keeping track of the system. You okay?
Yep.
So then O plays his first move in 4 and 6. X plays his next move in 2, 1. Just like any tic-tac-toe game, the first few moves is pretty pointless. You only get strategy in like move 4. So O then places his in 4 and 7. At this point, O just closed a loop. His second move in 7 refers to X1, which refers to 6, which refers to O1 over here, and then back to O2. So your closed loop is 4, 7, 6, 4. At this point, O can choose to observe the system, and let's say he just chooses this observation. So he's one move away from the win.
What if he doesn't observe that observation? What if he doesn't observe it? He just doesn't see it.
If he doesn't notice the loop,
And they just keep playing?
they keep playing until the loop's found. Yeah.
You don't get a claim a loop if somebody else didn't observe?
You know, the paper that did this, they didn't actually consider someone not seeing the loop.
Oh, okay.
So,
Consider me.
yeah.
If you don't see the loop and you move, so you must the next move.
Yeah, that's just a good rule of thumb. The next person who observes the system gets it. So if X makes his next move in 3, 5, so here's our X3 and 3 and 5. Let's let O make his final move here for this game in 3, 2. We have O3 referring to X2, referring to X3, back to O3. So our closed loop is 2, 3, 5, 2. O was the final person again, so they choose to observe the system. Let's say O makes a mistake. This is where this game is a little more difficult than tic-tac-toe, if you don't think it is already. Since you have an observation step in there, you can literally shoot yourself in the foot if you don't watch how the system collapses. So in this case, O got to choose the collapse, and if O wasn't paying attention, just handed the game to X.